Hi guys, welcome to Chapter 8. Hopefully you all had a good weekend. We're going to start with a couple of little warm-up problems and then we'll move right into the meat of the content. So if you don't remember how to do these, that's okay. Hit pause at the moment just to give them a try. But otherwise, let's go ahead and give them a shot. So, when I want to solve for r in these, I've got fractions on both sides. How do I get rid of them? Well, there are two choices. You could either divide by 7/8 on both sides and use the calculator to figure out what that is, or I like to deal with them in two steps. So I'll multiply both sides here by 8 to cancel out the bottom, which will get me 8 times 9 is 72. And then I will divide by 7 to cancel out the last piece. Now, I know that many of you are likely groaning at the moment, as is often the case. But sometimes you have to remember that fractions are always there. They're hiding in plain sight. So we can't get distracted or discouraged just from them existing. So let's go ahead and do the second one as well. So again, I've got a number in front of my m. It happens to be a fraction. I'm going to go ahead and cancel out the denominator by multiplying, just as always. And here, since 1 times anything is just itself, we'll get m equals 56 over 3. Now, it is important to remind you that when you're multiplying a fraction, whether it's by a whole number like here, or whether it's by another fraction, you always multiply across. So for instance, if you were concerned as to why 7/3 times 8 was 56, well, if we take a look at that for a moment, 7/3 times 8, we would write that as 8 over 1, and then multiply straight across, which is where the 7 times 8 became 56, and where 3 times 1 would become 3. The same thing is over here is how we got 72 over 11. You might say, well, wait, why is 72 over 11 become 72 over 77 if I divide by 7? Well, just like here, we can sort of blow that up and look at it real quick. 72 over 11 divided by 7 over 1. Well, when we do division with fractions, we always have to remember the phrase keep, change, flip. We keep the first bit. We change the sign to a multiplication, and we flip or find the reciprocal of the second item. And then again, just like before, we multiply across, which is where our 72 77s came from. This is just a little review of multiplying and dividing by fractions before we get into today. And if you need a moment, feel free to pause. I have one more sort of anticipatory set for you. Just want to remind you how to add and subtract fractions. And so again, if you remember a little bit of how to do this, go ahead and pause the video here. Okay, and by now I'm going to assume that you have already given this a try. So I would remind you that when you add or subtract fractions, you need to find a common denominator, a least common multiple. If I look at the numbers 3, 4, and 6, the easiest number I can think of that they all go into is the number 12. Well, how do I get them there? Well, if I want to make 3 into a 12, I'd have to multiply it by 4, and whatever I do to the bottom, I must do to the top. If I want to make 4 into a 12, I'll have to multiply it by 3. The same rule still applies. If I do it to the bottom, I must do it to the top. And if I want my 6 to become a 12, I'll have to multiply it by a 2. Again, remembering that I have to do whatever I do to the bottom to the top. So if I do all of my little multiplication pieces, I'll find that I get 4 over 12 plus 9 over 12 minus 10 over 12. And then for finishing up, we have to remember first and foremost that we always add from left to right. And that when we add fractions, our denominator doesn't change. If I have 2 pieces of pizza and 3 pieces of pizza, I get 5 pieces of pizza, but it doesn't change how many times the pizza was cut. So 4 plus 9 is 13. Minus 10 is 3, but it was still out of 12. And then if I can at the end, I'll try and reduce. Here, it looks like I can reduce both the top and the bottom by 3. 3 going into 3 once and into 12 4 times, giving me a final answer of 1/4. All right, so now that we've had a little review on fractions, you might say, well, why am I doing that? And the answer is because we're going to be doing fractions in a bit more of a sophisticated way. We're going to be simplifying rational expressions, and we're going to simplify complex fractions. Well, what the heck does that mean? Well, let's take a look at something like this. And I know immediately out the gate, you might be running to the hills, but it's okay. We're going to get through this. And the basic idea that's going on is we're going to do 2 things. We have 2 basic goals. One, we're going to do everybody's favorite F word in math, factor. We're going to factor everything we can. And then once we've factored everything we can, we're going to try and cancel things out. Well, what does that look like? Well, if I look here, I remember that I have a quadratic right there. This one's nice. I can look for something that multiplies to C and adds to B, our old factoring theorem. So if I think of numbers that can multiply to 3 and add to 4, what comes to my mind is the numbers 3 and the number 1. So I'll go ahead and rewrite that top with this piece factored into x plus 3 and x plus 1. On the bottom, I've got another quadratic, this x squared minus 9. And you might remember that this is a difference of squares. If you don't remember that theorem, it's okay. I could also write it like this, and then look for things that multiply to -9 and add to 0 if I've forgotten the other theorem, which is okay either way. And so if I think about it, numbers that multiply to -9 and add to 0, well, to my mind, I think of +3 and -3, right? +3 times -3 would be -9. And if I added them together, I would get a 0. All right, so step 1, factor. Check, we're good there. So now let's see, can we cancel anything? Well, to cancel something, it's got to be the same on both the top and the bottom, right? Just like those fractions we reviewed a few moments ago. Well, if I look at what we have here, I do see something I can cancel. I see x plus 3, exactly the same on both the top and the bottom, which will leave me with 5x, x plus 1, over x minus 6, x minus 3. Now I know that many people want to go back and start distributing here. Please don't. We want to keep these as factored as we can. And so with that, we've canceled, and we found the answer to this particular setup. We're simplifying as much as possible. I know that may not look super simple, right? We've got a lot of x's of multiplication, but when we say simplify, we mean pull everything, combine as much as we can, and get rid of as many of these quadratics or higher level exponents as possible. To do that, we again factor and cancel. Let's try another one. So if you want to give this a shot without me, go ahead and pause here. Okay, I'm assuming by now you've given it a try or you're looking for a little more help, which is either way is fine. So I'm going to look at this. I notice on the top there's nothing here that I can factor, so I can leave that as is. And how do I know there's nothing I can factor? Well, there's nothing that can come out of either of the parentheses. And of course, there's no squares or cubes or anything like that. On the bottom, though, I do have a square. I do have something that can come out. So again, I'll look for things that multiply to C and add to B. So if I look at -6 and -1, I'll think of numbers like -3 and +2. Because if we were to multiply them, we'll get the -6, and if we add them, we'll get that -1. And so then I can look at my secondary equation here, my factored form. I'll go to step 2, which is to cancel them. I only have one thing on the parentheses I can cancel, but there's one more here too. If I look carefully, not only is there a y minus 3, but both the top and the bottom also have a y. Not sure why I circled that, but hopefully you see that those need to cancel. And so when we simplify it down, we're left with 4, y plus 4 on the top, and on the bottom we canceled everything except for y plus 2. Ooh, that is an x. Much better. Now, please be careful. You cannot cancel things that aren't being multiplied. We're able to cancel this y here because they're being multiplied by the things around it. I cannot cancel the y's inside of these parentheses. They're not being multiplied. There's addition next to them. We can only cancel out, things that are being multiplied. Otherwise, they're stuck. It's sort of why fractions work the way we know them, right? If we think about a value like 15 over 25, most of you guys would tell me immediately, and this is just an example, of course, but most of you guys would tell me immediately that 5 cancels out of top and bottom. And you might be very quick to just say, look, it's 3 over 5, and I would agree. But the reason that works is because we can rewrite 15 as 3 times 5, and we can rewrite 25 as 5 times 5. And that allows it to cancel because we have multiplication going on. This is sort of the behind-the-scenes stuff that happens when we cancel things down. In fact, if we go back to our second POD, up here, right? Just a little side note. When we cancel this down to being 3 over 12 to 1 over 4, this really worked because we could rewrite 3 as 3 times 1 and 12 as 3 times 4, which allowed it to cancel. That's why we were able to cancel that down. So even in numbers, we still look for only things that are being multiplied. If that was 3 plus 1, it would be stuck. We wouldn't be able to do anything with it. Okay? So, in case you needed it, here's our solution to that piece. Let's take a look at something else. So here's another one. Again, we'll look for things to factor, and we'll go from there. Right off the bat, the thing that I see that I can factor is this z squared plus 2z minus 8. Of course, if you want to try, go ahead and pause the video. Well, let's go ahead and continue then. I'll assume that by now you've done so. And so I'm going to try and factor this out. I look at -8 and 2 and think to myself, +4 and -2 should give us our two values there, right? Because +4 times -2 will give us -8. And they'll add to +2. So z plus 4 and z minus 2 all over z minus 1. So I don't see anything on the bottom that we can factor. And now we'll look at everything here that can be canceled. And in truth, you could have canceled the z plus 5s earlier. I like to do it all at the same time personally. And then again, I see another thing we can cancel, z minus 2 here. So that will leave us with just a 2z and a z plus 4 on the top. On the bottom, we're able to cancel everything except for z minus 1. All right. Again, we don't want to multiply that 2z in. We want to keep it as factored as possible. Let's continue. So let's go back a step. We've done some canceling, but what about that good old-fashioned multiplication, right? And so I have some multiplication here of a fraction, but my fractions have something more than the usual numbers that we're used to, like in the POD. We've got some letters going on here. And the basic attempt here that we're going to try and always do is whenever we have multiplication, and I want to really sort of emphasize that, when some things are being multiplied, like we're multiplying these, the whole thing, right? I want to try and cancel as much as I can. Now we know we can always cancel up and down, but when you're multiplying fractions, you can also cancel diagonals. So for instance, here, I have a 15 and a 5. So if I look at that, I can cancel the 5 out of both. Just like I can do something similar over here with my 6 and my 8. I believe 2 goes into both, allowing things to become a little simpler. But wait, there's one more. Not only can we do numbers, but letters are also possible. So I have a D here, and a D squared will become just 1D. Now you might say, well, what's going on there? Well, I would remind you that D squared literally means 2 Ds. So if I cancel 1 down here, I'm canceling 1 out of this one. That's why it becomes a singleton. There'll be one of the 2 left at the end. So if we multiply across, like we do for all fractions, we'll get 3 times 3 is 9. We have 2 C's and 1 D left. A single C from the left and a single C from the right. And on the bottom, well, 1 times 4 is 4, and we have an A. Now, even though we did a great job of simplifying things as much as possible, we always want to do one extra check and make sure that we didn't miss anything, make sure there's nothing we can simplify over here. I would say that I don't see any letters on the that are the same on the top and the bottom. And I don't think 4 and 9 can go into each other, so I do believe we've simplified as much as we can. So let's try an example. So another multiplication one. Why don't you go ahead and pause the video here and give this a try. Okay, and I'll assume that you've done that by now. So let's look for things that we can cancel, things that we can make go away. Well, as far as up and down goes, I don't see anything that overlaps. We do have some diagonal stuff. So specifically, or do we have any diagonal stuff? 3 and 6, 9 and 2, 5 and 7. Maybe we don't. Sometimes stuff doesn't simplify so nicely. Let's multiply across and see what happens. So 18 times 12. I'll go ahead and cheat and use my handy dandy calculator. I recommend you do the same. Looks like 216. We'll have an x and an x squared is x cubed. 3 y's and 1 y will become y to the 4th. So we don't want to forget that there are little ones hiding here. On the bottom, we'll multiply across. 7 times 35. 245. A to the 2nd and a to the 2nd is a to the 4th, as well as b to the 3rd. Again, that hiding 1 right here if you want to write it in. And don't, of course, forget that when you multiply bases, we add exponents. And I do believe that is as simplified as we can make that one. So don't be fooled. There isn't always something to cancel. If we look at the next one, maybe this one will work out a little bit better. See, initially, this looks the same, but there's a major, major difference here. And that's this guy in the middle, right? That division symbol. And that's going to change everything very radically. So as always, when we deal with division, we think of what I like to call messy chicken, KCF, keep, change, flip. So we'll keep the very first piece, 18, x, y to the 3rd, over 7a squared, b squared. We will change division to multiplication. We will flip the secondary part. So 35 a squared b over 12 x squared y. Now, since we've made it into multiplication, we can go back to doing the same thing we did before. We'll look for things to cancel, and then we'll multiply straight across. And now all of a sudden things cancel really nicely. I have one x here that cancels out one of my x's over here. I have one y here that cancels out one of my y's up top. In the other direction, we've got a b here, making that a singleton b. I've got an a squared here, 2 a's that cancel both of these a's. But wait, there's more. We can cancel out a 6 from both the 12 and the 18. And a 7 from both the 7 and the 35. See, sometimes division makes things easier. We'll multiply across. 3 and 5 is 15. I have a y squared left here and no variables over there. On the bottom, well, 1 and 2 is just 2. Both of these variables canceled except for the b over here. I lost my y, but I still have an x. I take one last look. I don't see any variables that are the same on the top and bottom. 15 and 2 certainly don't have anything in common, so I believe we're good. Some division. Now, sometimes we go to factor and things look really close like they should work. Let's see if we can factor this out and see what happens. Well, I look at these and I don't have a squared here in the same way that I might have a problem earlier, like some x squared plus a number, x minus a number. But I do have something here where I can pull a single target out of both of these. If I look carefully, I'll see that there's a w in both of these terms. So our old factoring skills would say that we want to take one of these w's and pull it outside. So if I do that, if I take a w out of 4w squared, that's going to make me have 4w. because this had to, and we took 1 out. Next to here, we're taking out a w. We're going to be left with minus 3y. And of course, the second one we can't change. In the bottom, I don't see anything we can factor. But we do have something that's a little annoying. And what I mean by that is that these two right here are really, really close, right? 4w and 3y, they're the same numbers, but they're coming in opposite orders. In fact, if I look at it, the 4w here is positive and it's negative in the bottom, and vice versa for the 3y's. If I ever have a case where I need to swap their positions, what I can do is I can use a -1. See, we know that we can multiply anything by 1 and not change it, right? We can all agree that 4 times 1, for instance, is 4. Well, we can be creative with our 1's. For instance, anything that multiplies and cancels to 1 could also be used. So for instance, I could, instead of multiplying 4 by 1, I could multiply it by -1 twice. If I did, the first time would make it negative, and the second time would make it positive again. These are effectively the same thing. Well, you might say, well, what's the point to that? Well, if I introduce 2 -1's on the bottom, look at what happens. My top will stay the same. On the bottom, I'm going to introduce 1 -1 in front, along with the other, 5w plus y. And now I'm going to choose, because as humans we have the ability to use our pattern recognition to make a choice, to distribute one of these -1's into the part that I want to flip, but not the other. So if I do that, my top remains the same. But on the bottom, because I'm choosing to distribute in one of those -1's, I'll leave the first one on the outside. I'm not changing that one. But if I multiply these by -1, well, my -4w here will become positive. And my 3y will become negative. And so sometimes we'll call this taking out a -1. Because it looks like on the outset that I've taken a -1 out of here, but you can look at it either way. By introducing those extra -1's and distributing only one of them, I was able to turn these two numbers around. And now, since they're the same, they can be canceled. Again, notice before they were opposites. I couldn't cancel them. Now I can. I don't see anything else here we can cancel, so our final solution then is w times w plus y over -5w plus y. We can choose to leave one of those negatives on the outside, and that allows us to flip those terms and cancel them. Let's take a look at some more. So let's see what we need for this one. Go ahead and pause me here. Give it a try without me first. Okay, and I'll assume that you have done that. Let's see if we both get the same solution. So on the top, first things first, I notice that I have a z in both of these. Let's go ahead and pull that out. That'll leave us with just x left out of xz and just 4 left out of 4z. On the bottom, we have z squared and 4 minus x. And so we've come to that same crossroads as before. I'd really like it if these were flipped, or if these were flipped so they were the same. So I'm going to go ahead and introduce -1's. I'll do it on the top this time, I guess. I'm going to add a negative, and then I'm going to be allowed to flip what's inside. Now this looks a little sneaky, but you'll see that my first -1 came in right there, and my second -1 flipped this from being x minus 4 to 4 minus x. As long as you introduce both of them on the same side of the fraction bar, you're good to go. And so again, 4 minus x and 4 minus x cancel. I have a single z here that can cancel one of the z's out. We'll be left with -1 over z. We have a couple more. Let's give this a try. Go ahead and pause the video. You want to give it a shot? I'll assume you've done that by now. So if I look at the top, it looks like I can take both an A and a B out of both of those, leaving me with just a single B on the inside, minus just a 5. On the bottom, of course, it won't change. I'll go ahead and I guess I'll add my 2 negatives into the bottom so that I can make these guys cancel. So my top will remain the same. My first negative I'll put out front. My second negative I'll use to flip these guys. Now we can cancel. So AB over negative 5 plus B. Okay. I believe I have one more for you. So again, oh, actually this is more than a pause, another concept at least. Complex fractions. Well, I can almost hear in my head a couple of you guys going, what the heck is this? Well, it looks really terrible, but it's not actually that bad. See, this guy just means division. So this whole big thing literally just becomes a plus b over 4 divided by a squared plus b squared over 4. Okay. Well, let's go ahead and follow our usual process here. Keep change flip. We'll keep the front. We'll change that and we will flip over. Now, there's a little trick hidden here. While you can certainly cancel the 4's down, don't be fooled. Remember what we said. We can only cancel things that are being multiplied. I cannot cancel an A from an A and a B from a B when they have this addition symbol between them. They're actually stuck there. So we're just left with, very simply, multiplying straight across, A plus B over A squared plus B squared. And we're done. Let's do one last one. So again, this implies the top bit, x minus 2 squared over 2 times, and we can go ahead and factor this since we're looking at it. If I think of things that multiply to positive 4 and add to negative 5, I would think of x minus 4 and x minus 1. We're going to divide all that by x squared minus 4 over 4x minus 10. And I would look at that and say x squared minus 4 is another factorable object. So I can factor that into x minus 2 and x plus 2. If you've forgotten the difference of both squares, you could also think of it as x squared plus 0x minus 4, which is why the positive and negative 2's work. And if I look at 4x minus 10, I see that there's one number that goes into both 4 and 10, which is 2. So 2x minus 5. And now we can keep change flip, keeping the top part, or the first part rather, x minus 4, x minus 1, change the center, and flip the second piece, that reciprocal. And so things that we can cancel, well, we can cancel a 2 and a 2. And we can also cancel one of the x minus 2's with this one. Notice that this x minus 2 is being multiplied by itself. That's the literal definition of a square. And this x minus 2 is being multiplied by x plus 2. Because they're in parentheses, we can cancel them as if they were just normal numbers like these guys, because the quantity is being multiplied. And so last but certainly not least, we can multiply straight across. We'll get x minus 2 times 2x minus 5. And on the bottom, we'll get x minus 4 times x minus 1 times x plus 2. And that's about it. So hopefully this has helped you guys out a little bit. Of course, as always, you can email me if you need any help. Good luck on the homework and have a great day.